Okay, well, now looking at another important part of a curve, which is called the point or points of inflection. Like there might be one or more, or there might be none. But the point of inflection, which I'm going to abbreviate as POI, is the point where there's a change in concavity. So here we've got concave down, and on the other side I've got concave up. So this is a point where the concavity changes. Okay, so just copy that and come across when you're ready. Okay, so there are two tests for a point of inflection. The first test is the easy one. The second derivative equals 0, and the second test, which is important, is the second derivative changes sign on either side of the x value that we find. Okay, copy that and come across. So why do we need two tests? Well, let's have a look at a case where there's no change in concavity. So for instance, if I sketch y equals x4 on Desmos, I get a fat looking sort of parabola shape, and there is a concavity, but there's no change in concavity. And let's see what happens. So y dash equals 4x cubed, which will help me find the turning point. Okay, I don't worry about that. Y double dash is minus 12x squared. So if we only had one test at the POI, y double dash equals 0, so 12x squared equals 0, so x squared equals 0, so x equals 0. So I get that equation. Now, on either side, when I chuck in those values, I get a positive number and a positive number. Okay, so there's no change in sign, and we don't have a change in concavity. Okay, so we need to have two tests. Otherwise, this test would say there is a point of inflection at 0, but there isn't one. Okay, so the second test is important. So copy that, and we'll do some examples of where you can actually find POIs. Okay, so we've done this one before. So I've done the first derivative and I've done the second derivative. So at a POI, y double dash equals 0. So minus 6x equals 0, so x equals 0. So I've still got a 0 answer, but now let's look at the second test. So x and y double dash. So 0 is the magic number, so something to the left, something to the right. So when I put in minus 1 into minus 6x, I get a positive number. And then when I put positive 1, I get a negative number. So I have a sign change. So there's a sign change in y double dash. So that means that there is a POI at x equals 0. Now once I've done that, I'll find the y value. So y equals 4 plus 3 times 0 minus 0 cubed equals 4. So the POI is 0, 4. Okay, so copy that and come across when you're ready. Okay, so there's a special point of inflection where we don't have necessarily a roller coaster. So let's have a look at y equals x cubed. Okay, now I sketched it on Desmos and you get that sort of shape. So let's have a look at why there isn't a turning point. So we do the y dash calculation and get 3x squared. So if there was a turning point, y dash equals 0, so you solve the equation, so you get an answer of x equals 0. And then using the second derivative test that we've learnt earlier, okay, y double dash is 6x, so at x equals 0, y double dash equals 0, okay, but we had to get a positive number or a negative number to get a max or a min TP. Now 0 isn't positive and 0 isn't negative, so that's why there's no turning point, because we either had to get a positive number or a negative number to get, okay, so if it was a positive number, it would have been a min TP, and if it had been a negative number, it would have been a max TP. But we didn't get a positive or negative, so there's no TP. So when we do the POI calculation, we'll do the first test. So y double dash equals 0, so 6x equals 0, so x equals 0. That's okay. So 0 is the middle number, left and right. So when I put minus 1 into double dash, I get a negative. When I put positive 1 in, I get a positive. So there is a sign change. So therefore there is a POI at, and the x value we found was 0, and then when I chuck it into original equation, 0. But it doesn't look like there's an obvious change in concavity, but there is. Okay, this is concave down, and then this is concave up. And this POI is called a special POI. It's called a horizontal, H for horizontal. It's called a horizontal point of inflection. Okay, so it's still a point of inflection, but it's called a horizontal point of inflection. Okay, so copy that down and come across when you're ready. Okay, so I'll load a worksheet on Moodle. It's not covered in the textbook per se. There's stuff on second derivatives, but not necessarily on points of inflection, which we're going to use in our curve sketching later on.